More examples for solving systems of equations by substitution. I said we'll do some of the extra examples here on this second one. So this would still be a great example to do by substitution because it's going to be very easily to get that x alone. Keep my original equation safe, get my answer blank ready. So I'm going to solve this for y, or sorry, for x. Easy to get x alone here. I could just as easily get the bottom one, solve it for y, but then I'd have fractions all over the place. So again, that's our way of deciding is what's it going to be easy to get alone? Well, it was easiest to get x alone. That 10 is positive. Now I have this chunk of stuff that x is equal to. And so when I write my other equation, 3 times something plus 6y equals 8, this is the something that goes down into there, negative 2y plus 10. I'm going to distribute, again, those same steps each time, negative 6y plus 30 plus 6y equals 8. When I combine my terms, what happens? I have negative 6 plus 6. That's 0. These guys go away. They cancel each other out. So what does that mean? That means no solution. Why is it no solution? Because 30 does not equal 8, right? Because this is a false statement. There's nothing that will work. And when we get to graphing, we'll find out that that means those lines are parallel. If I put them both into slope-intercept form, they have the same slope. They will never intersect. Okay, so this one, no solution. Okay, so again, I still have that answer blank there, so I like to kind of still wrap things up. Okay, let's do one more before we get to our word problem. So we get x minus y equals 4 and negative 6x plus 6y equals negative 24. Keep our equation safe. Make our little area here for our answer. And looks like it's going to be easiest to solve that top equation for x. Almost as easy to solve it for y, but a little bit easier to solve it for x. So those y's look like 4's, don't they? X equals y plus 4. Could have just as easily have said 4 plus y. That's the chunk of stuff that's going to go down into the next problem. The other equation, so we have negative 6 times some stuff plus 6y equals negative 24. Some of you can see where this is going. When I put this stuff down into there, y plus 4, so we have negative 6y minus 24 plus 6y equals negative 24. So this time, just like last time, I have negative 6y plus 6y. No, it's not always 6 and it's not always y. But my variables have the same number coefficient with opposite signs. So I have 0y. I have no more letters left. What's different this time is I have a true statement. Negative 24 is equal to negative 24. I have a true statement. That's different than last time. Last time I had different numbers on each side. So this time it's infinitely many solutions. And so this is really one equation wearing a costume. It's really one and the same equation. Infinitely many solutions. So anything that would work in the first one, like 4, 0, it would also work in the second one. 0, -4, that would work in both of them also. Anything that works in the first one will work in the second one. It's one line. Everything in the bottom one's just been multiplied by -6, right? The swim team sold some t-shirts. They sold long sleeve shirts for $15. So as I'm reading this, I'm just kind of pulling out what I think is important. And so I have $15 for long sleeved, and I have $10 for short sleeved. They collected a total of $230. There's also another total. There's a total of 19 shirts. So as we start putting this together, it's a little artificial because now, I'm telling you, hey, this is a system of equations. We've done some problems that were similar to this where you could only use one variable. So now I'm saying 2 variables are fair game. And we know we're going to want 2 equations. So I'm going to say, well, one of my equations, if I look at my 2 totals, right, I've got 19 is one of my totals, and I've got 230 is another one of my totals. Well, what is this 19 going to be with? Let me move that down a little bit. I've got 19 is one of my totals, and I've got 230 is my other totals. Well, what is my 19 the total of? And it's not that you're always going to have 2 different totals, but on this one you do. 19 is the total number of shirts. So I'm going to have one equation that's just dealing with the total number of shirts. Well, what else do I know about shirts? Well, I know there was 2 different kinds. So as I start thinking about this, I start thinking about how do I want to define my variables. So I'm going to use X to stand for my long sleeve shirts and Y to use short sleeve. I could use L and S, but my 5s look like S's, my S's look like 5s. So I'm going to use X and Y. So I know that X plus Y is what's going to equal 19 because I sold either 1 and 18 or 2 and 17 or 10 and 9, something like that. So X plus Y equals 19. That's one equation. Now the money equation, I can't just say X plus Y because I know that equals 19. Well, how do I get the money in there? Well, if each long sleeve t-shirt costs $15 and each short sleeve t-shirt costs $10, that's how I'm going to have my other equation that has to deal with money. It's not always going to be shirts and money. It's not always going to be they give you 2 totals, but this one was pretty straightforward. If you're comfortable with these, you'll get, probably 3/4 of them. So I'm going to write that because I'm still reminding myself I'm looking for them, but it's really important to read what they're looking for because sometimes they'll just ask you one, and if you answer both, that doesn't make sense. It means you didn't read the question. Or they'll ask you one and you answer the other. They like to do that, especially on multiple choice tests, just ask you one because then it's real easy to answer the wrong thing. So I'm going to solve this equation. I'm going to solve that first equation for Y. So I'm just going to subtract X from both sides. So I've got Y equals -X plus 19. Well, let's not put a box around that. Okay, so this is the stuff that's going to go in place of Y. So now I'm going to go to the other equation, and I have 230 equals 15, writing too big. 230 equals 15x plus 10 times whatever y was, except for now y is -x plus 19. So I can distribute. I have 230 equals 15x minus 10x plus 190. Worked out nicely that I used x too. Actually, when I did the example, I solved for y, and the numbers weren't as pretty. So think about why was it easier this time? Because I only had to times 19 by 10 instead of by 15. Okay, one more step here. Yeah, the math's definitely easier this way. So we got 5x equals 40, so x equals 8. Now it's important to know, what was x? X was the number of long sleeve t-shirts. So they sold 8 long sleeved shirts. And so then it's just 19 minus 8. We can do the math because sometimes it's not that easy, but if we know this is 8, then we know that this is 11. So, and 11 short-sleeved shirts. And if I did 10 times 8 would give me, no, 15 times 8 would give me 120, and then 10 times 11 would give me 110. 110 plus 120, that's 230. So there's my verbal version of a check. And verbally checking is fine if you're not asked to show it. If you're asked to show it, you need to show it.